What if the biggest reason you're still an intermediate JavaScript developer isn't your talent, your effort, or even JavaScript itself? The real answer has been hiding in plain sight all along. Thousands of developers spend years writing JavaScript every day, yet many stop improving much earlier than they realize. The surprising part is that JavaScript itself isn't actually the problem. Most people believe that experience automatically creates expertise. 5 years of JavaScript should make you 5 times better than 1 year. It sounds obvious, but software engineering has never worked that way. You can repeat the same habits for years and simply become faster at doing the same things. JavaScript just happens to make that trap unusually comfortable. Think about how most developers begin. They build a landing page, then a portfolio, maybe a React application, a dashboard, or an API. Every finished project feels like real progress. The code works, users click buttons, everything behaves exactly as expected. It feels like proof that you're getting better because in many ways, you actually are. But progress and mastery are not the same thing. Confusing the two is where many JavaScript developers unknowingly stop growing. Psychologists describe something called the competence illusion. When success comes consistently, your brain naturally assumes your understanding is growing just as quickly. Sometimes that's true, but JavaScript is incredibly good at making developers productive before they're deeply knowledgeable about the systems beneath everything they build. Modern frameworks, TypeScript, package managers, and AI assistants remove enormous amounts of complexity. Together, they create an environment where the real learning can quietly stop. These tools are remarkable achievements, but together they create an environment where you can build increasingly complex software while understanding surprisingly little about the systems beneath it. That's exactly where the plateau begins. Everything still works, projects keep shipping, but your understanding stops growing at the same pace as your productivity. Notice what happens when an experienced JavaScript developer encounters a difficult bug. If the problem lives inside their own code, they usually solve it without much trouble. But once the bug crosses into browser rendering, memory behavior, asynchronous execution, or the JavaScript engine itself, many developers suddenly feel completely lost. The project has quietly become much larger than the mental model they built. And that's not a personal failure, it's simply the consequence of abstraction. Every abstraction exists to reduce cognitive load. That's exactly why tools like React, Node.js, ORMs, and cloud platforms make developers so incredibly productive. But every abstraction also creates a choice. Will you eventually learn what's happening underneath, or will you simply trust that everything works without asking why? Intermediate developers usually choose trust because it's faster. Advanced developers eventually choose curiosity, even when exploring deeper systems feels slow and uncomfortable. That decision sounds small, but over the years it changes entire careers. 2 developers can write similar code today and become completely different engineers tomorrow. Imagine 2 developers with identical jobs. Both spend every day building React applications, but what they choose to learn after work quietly shapes everything that follows. One developer finishes tickets quickly, then spends evenings learning another framework because everyone online says it's the future. The other chooses a very different path. Instead of chasing another tool, they spend one evening understanding how the browser event loop schedules tasks, why microtasks run first, and what the JavaScript engine is actually doing. After 6 months, both developers are still building applications that look almost identical. From the outside, there isn't much difference between them. But 5 years later, one developer understands software itself, while the other mainly understands the tools someone else built. The industry often rewards the first path in the short term, but over the long run, the deeper understanding becomes far more valuable. If you've ever wondered why senior engineers stay calm during production incidents, this is usually the reason. They've built stronger mental models of how systems actually work. Instead of searching for matching error messages, they reason from first principles. They understand why the system behaves the way it does before trying to fix it. JavaScript also encourages another psychological habit that very few developers ever stop to recognize, even though it quietly shapes their entire learning journey. That habit is novelty addiction. The JavaScript ecosystem changes so quickly that every new framework or runtime feels like the next important thing to learn. Learning each new technology feels productive because every fresh API and every new project gives your brain another small reward, making it easy to confuse excitement with real progress. But novelty isn't mastery. Real mastery is often repetitive, uncomfortable, and surprisingly boring because it requires revisiting the same concepts until they become part of how you think. It's much more exciting to announce you're learning the newest framework than to spend an entire weekend understanding how garbage collection affects memory in long-running applications. Yet only one of those activities permanently changes the way you think. Deep understanding stays with you long after today's popular framework disappears. That's why many developers have impressive GitHub profiles but struggle during system design interviews. They've collected technologies instead of building mental models. There's another trap hiding inside JavaScript culture. And unlike novelty addiction, most developers don't notice it until much later in their careers. Optimization usually arrives too late. Most JavaScript applications begin small, so performance problems remain invisible until the software starts growing much larger. At first, everything feels fast. The application handles hundreds of users without difficulty, so nobody worries about rendering costs, memory usage, or unnecessary network requests. Then the product becomes successful. Suddenly, tiny technical decisions become measurable problems affecting thousands or even millions of users every single day. That's why companies operating at massive scale invest heavily in front-end performance. Faster applications improve user experience, engagement, and sometimes even business success. The developers who understand browser internals, rendering pipelines, networking, caching, and memory management become incredibly valuable because they solve problems most developers never even notice. The interesting part is that these developers rarely learned those topics because someone forced them to. They learned them because they became fascinated by questions that most people never even think to ask. Why does this repaint happen? Why was this function de-optimized? Why is this bundle so large? Why does this memory never get released? Curiosity creates depth. Deadlines rarely do. Finishing software is important, but understanding why it behaves the way it does is what transforms how you think. Now let's talk about AI. Many people believe artificial intelligence will eliminate the need to deeply understand JavaScript. Ironically, it may make that understanding even more valuable. Today, almost anyone can generate working code, but generating code has never been the same thing as understanding why that code actually works. Large language models are incredibly good at producing familiar patterns, but once architecture becomes complex, perform matters, or debugging crosses multiple systems, human judgment becomes essential. If your workflow becomes accepting generated code you don't fully understand, you're slowly outsourcing the very skill that separates intermediate developers from true experts. The most effective engineers don't reject AI, they challenge it. They ask why a solution works, why one algorithm is better, and why the browser behaves the way it does. The questions matter far more than the generated answers. Better questions create deeper understanding, and deeper understanding creates better engineers. History has shown this before. Every major productivity breakthrough changed what skilled engineers focused on. AI appears to be following exactly the same path. When calculators became common, mathematicians didn't disappear. Arithmetic simply became cheaper, allowing people to focus on solving much deeper mathematical problems. Compilers didn't eliminate programmers either. They automated repetitive work so developers could spend more time solving larger and more meaningful engineering challenges. Garbage collectors didn't eliminate systems engineers. Every productivity breakthrough simply moved the valuable skill one layer higher instead of making expertise unnecessary. Artificial intelligence appears to be doing exactly the same thing. The developers who succeed won't simply write code faster, they'll understand software more deeply. Perhaps the biggest difference between intermediate and advanced JavaScript developers isn't intelligence. It's something much simpler and much more uncomfortable. Experts willingly spend time where they feel incompetent. They deliberately explore topics they don't fully understand instead of avoiding them. They read technical specifications, they study browser engines, they inspect source code. They profile applications instead of relying on assumptions or quick guesses. They eventually learn networking, operating systems, databases, security, accessibility, concurrency, and architecture because they realize JavaScript isn't the destination. It's simply one doorway into computer science. And the moment you realize that, the way you learn software begins to change completely. That realization changes everything. You stop collecting frameworks and start building a deeper understanding of the systems that make modern software possible. The irony is that JavaScript has never been the obstacle. It's one of the most flexible, influential, and successful programming languages ever created, powering software almost everywhere. It powers browsers, servers, desktop applications, mobile apps, embedded devices, and even modern AI tools. The language itself isn't what keeps developers intermediate. Comfort is the real obstacle. The longer you stay inside familiar tools without questioning how they work, the slower your growth becomes. The moment you stop asking, "How do I build this?" and start asking, "Why does this system behave this way?" everything begins to change. Your learning accelerates in ways another framework never could. You're no longer memorizing tools. You're building a mental model that applies across every technology you use. Developers who remain intermediate become slightly better JavaScript developers every year. Exceptional developers eventually become lifelong students of computing itself. That's the real difference. One path builds better JavaScript developers. The other builds better engineers capable of understanding almost any system they encounter. If this video changed the way you think about learning JavaScript, let me know in the comments. I'd love to hear which concept had the biggest impact on you. And if you enjoy exploring the psychology and deeper philosophy behind coding, subscribe for more videos like this. There's always another layer waiting to be explored. Because beneath every framework, every programming language, and every line of code, there's always another layer beneath the surface, and that's where real mastery begins.